All right, so today we are going to work on the review for our quadrilaterals test. So we start with our Venn diagram. The whole we're dealing with is quadrilaterals. Our quadrilaterals, based on the number of parallel sides they have, can be broken down into trapezoids if they only have one pair of congruent sides, or parallel sides, excuse me, and our parallelograms if we have both pairs of opposite sides parallel. Within our parallelograms, we can look at, do we have all the angles congruent, or do we have all the sides congruent? If we have all the angles congruent, we have a rectangle. If we have all the sides congruent, we have a rhombus. And if we have both the sides and all the angles congruent, we have a square. Within our trapezoid, so we have the one pair of parallel sides. If we have the other pair of opposite sides is congruent, we have the isosceles trapezoid. So there's our Venn diagram. We look at number 2, we have a trapezoid. So all we know is that we have the one pair of parallel sides. Well, if we think back to our parallel lines unit, we have our parallel lines cut by our transversal. So we know that these consecutive angles right here would have to add to 180 degrees because they're same side interior or consecutive interior. Be careful, not every pair of consecutive angles will add to 180, only the ones that are in between your parallel lines. So the ones I've marked in black and also the ones that are marked in purple. Those are your only two pairs that will add to 180. So if we look at 2b, we have to, based on the property, write an equation. Well, if we look at our two angles we circled in black, we know the 13x plus 20 plus 5x minus 2 has to equal 180 degrees. If we look at the ones in purple, 10x plus 8 plus 8x plus 10 has to equal 180. Again, you only need one pair. You don't need both of them. So the next one, we have to write out the equation. Well, we already just said it. 13x plus 20 plus 5x minus 2 equals 180. You also could use the purple pair, in which case that's 10x plus 8 plus 8x plus 10 equals 180. Again, you only need one of the pairs. We go to the next page and we look at number 3. What are all the properties that apply to all rectangles? Well, since a rectangle is a parallelogram, we know opposite sides are congruent. We know diagonals bisect each other. We know our consecutive angles are supplementary. And we know our opposite angles are congruent. We then had a couple special properties that made a rectangle, and those were that all of our angles were congruent and our diagonals are congruent. Since all of our angles are congruent and our consecutive angles have to be supplementary, that means our consecutive angles would have to be congruent in a rectangle. So then we move on to number 4. We're going to use our properties of parallelograms. Well, in A, we have that 10 is half of our diagonal, and the other half of our diagonal is 2x minus 4. And since our diagonals bisect each other in a parallelogram, we know that those two halves have to be equal. So 10 equals 2x minus 4. We solve our equation. We get 14 equals 2x, so we get x has to equal 7. The next one, we are given consecutive angles, and we know consecutive angles are supplementary. So we know that x plus 9 plus x minus 9 has to be 180 degrees. We add the two of them together. So we get that x is 90. In C, we're given opposite angles, and we know opposite angles are congruent, so we set them equal to each other. Solve our equation. So we get that x equals 20. Number 5, we have another parallelogram. To solve for x and y, we know that our opposite sides are congruent, so we know that 30x would have to be 150. And then we know that 2y has to equal 72x. Well, since we need to find x and y, we're going to start with the equation that only has one of them. So divide by 30, we get that x is 5. Then in our other equation, we're using both x and y, but we know that x is 5, so we plug it in. We get 2y equals 360. Divide by 2, we get y equals 180. Number 6, we don't have our picture, so we draw it out. We name our corners, being careful of our order. We know that AB is 6x plus 5. We know that DC is 35, and BC is 2x plus 10. So we know our opposite sides are congruent, so 6x plus 5 has to be 35. We're going to solve that so that we can find x and then find BC. So 6x equals 30, which means that x is 5. Well, then it tells us we also have to find BC. Well, we know that BC is 2x plus 10, and x is 5, so we plug it in. So we get that BC is 10 plus 10, so BC is 20. Number 7, be careful. We have that RB is 5x minus 13. All right, so since RB is half of our diagonal and our diagonals bisect each other, that means that BT also is 5x minus 13. So RT is 2 times 5x minus 13, or 5x minus 13 plus 5x minus 13. You still get the 10x minus 26. So then we know our diagonals are congruent since we have a rectangle. We know RT is 10x minus 26. SQ, which was given to us, is 4x minus 2. We set them equal to each other and solve. So we get that x equals 4, and then we go back and we plug it in to figure out the length of our diagonals. So 4 times 4 minus 2 is 16 minus 2. So our diagonals have a length of 14. Number 8, we have an isosceles trapezoid. So we know we have the one pair of parallel sides that are opposite each other, and then our legs are congruent, so which means our non-parallel sides are congruent. So then it's easy. We know that x has to equal 12 centimeters. Flip over to the next page. Number 9, we have a parallelogram. We know that this angle in the corner at H is 90 degrees, and since our consecutive angles have to add up to 180 degrees, all of our angles, corner angles, are in fact 90 degrees, and since angle 7 is a whole corner angle, angle 7 is 90 degrees. So then we look at angle 3. Well, the 52-degree angle and angle 3 have to make a linear pair. So we know the two of them have to add to 180. So to figure out angle 3, do 180 minus 52, and we get 128 degrees. Since angle 4 and angle 3 are vertical angles, angle 4 is also 180 degrees. Then, to figure out angle 2, we're going to look at this triangle right here. Since we have the rectangle, we know all of our pieces of our diagonals are congruent, which makes SHT a isosceles triangle, so we know that angle 2 and angle 6 have to be congruent. And we know the triangle has to add up to 180 degrees. We've already used 52 degrees. So between angle 2 and angle 6, we have 128 degrees to work with. Since they're congruent, divide it by 2, and we get the angle 2 and angle 6 are 64 degrees. Then, to figure out angle 5, well, look here. We have two parallel lines cut by a transversal. Angle 2 and angle 5 are alternate interior angles. So angle 5 is also 64 degrees. Then we have left over is angle 1. We know that angle 2 plus angle 1 has to be 90 degrees. So we know angle 2 is 64. So just subtract it from 90 degrees. And we get that angle 1 is 26 degrees. Number 10, we're going to use the fact that our rectangles have 4 90-degree angles. Since these are all 90 degrees, we know our consecutive sides have to be perpendicular. Two lines that have intersect at 90 degrees are perpendicular, and we know that perpendicular lines have opposite reciprocal slopes. So if AB has a slope of 6 over 5, then we know that AD would also have, or I would have a slope of the opposite reciprocal of that, which is negative 5 over 6. And then since our opposite sides are parallel and parallel lines have the same slope, we know that BC also has a slope of negative 5 over 6. And then since AB is parallel to CD, DC has a slope of 6/5. We look at number 11. Number 11, we have a rectangle, which means we know we have right angles. The first part for number 11 says we have to solve for y. I'm going to outline my angle y. Well, if I continue this triangle, I have a right triangle, which I'm going to redraw. Here's angle y. Here's my right angle. This is 5 feet. This is 13 feet. Well, I'm looking for an angle, so I have to use trig. Here's our person. Right across from them is our opposite side, which is 13. Right next to them is 5, which is our adjacent side. So then, thinking back to SOHCAHTOA, we know opposite and adjacent would be our tangent. So the tangent of y would equal 13 over 5. And since we're looking for the angle, we need to use the inverse trig function. So we get that y is equal to 68.962 degrees. And then we need to figure out angle DBA, which I am outlining in blue. Well, if we continue that triangle, we know AE and BE are congruent because we have a rectangle and the diagonals are congruent, which means that angle Y and the angle we are looking for are congruent, which makes angle DBA 68.962 degrees. Then angle X is the leftover angle. So we know that angle Y and the measure and angle DBA and angle x have to add up to 180. So add up our two angles we do have. And that gives us 137.924 degrees. Subtract that from 180, and we get 42.076 degrees. Number 12, we have a rhombus, which means we know all of our sides are congruent. Our diagonals bisect each other. Our diagonals are perpendicular, and our diagonals bisect the opposite angles. So now that we have our whole picture labeled, we can look at what we have. So if we're looking for DAE, outline it in blue. Well, let's see, we have a right triangle, we have the 90-degree angle, we have a 28-degree angle. We know that the three angles combined have to make up 180. So add the two we have, subtract it from 180, and we are left with 62 degrees. Even though I just marked everything up, I'm going to erase it to make the next step look a little less confusing. BD. Well, we know that our diagonals bisected each other, so since DE is 15, BE would also be 15, which makes BD 30 inches. Then we get to part C, angle DBC. If we think back to our original markings, all of our opposite angles were bisected, which means that angle DBC is congruent to the half of the one opposite that angle. So DBC is 28 degrees. For part D, we know it's a rhombus, which means all of our sides are congruent. So since CB is 17, AB is also 17 inches. And then to figure out AE, the one I have marked in red, I'm going to use this triangle. I know BE is 15, I know AB is 17, so I can use the Pythagorean Theorem to solve for BE, or AE, excuse me. X squared plus 15 squared equals 17 squared, so x squared plus 225 equals 289. X squared equals 64. Square root that. We get x equals 8 inches. And then we move on to the next problem. Number 13, we have our square. For A, we're looking at angles. We know our diagonals are perpendicular, which means that 3p would have to equal 90 degrees. Divide by 3, p is 30 degrees. We also know that our corners are 90 degrees, and since a square is a rhombus, our opposite angles get bisected, which makes both r equal to 45 and 5t equal to 45. So there's r. To get t, divide by 5, so t is 9. Then we need to look at part B. Part B, we need to figure out x and y if BF is 4x minus 2, AF is 3y minus 3, and FC is 3x. Since it's a square, I know all of my pieces of my diagonals are congruent. So to solve for x, I need to pick the two pieces that involve x. So I can use 4x minus 2 equals 3x. Bring my x over to the other side. I get negative 2 equals negative x. But I want positive x, so x is 2. Then to figure out y, I only have one half that actually uses the y. So I have 3y minus 3. And then I know what x is, so I can pick either piece that involves x to plug in x. So I'm going to take the 3x, and then I plug in that x is 2. So I get 3 minus 3y minus 3. Add the 3. 3y equals 9, which means that y equals 3. Okay, so we continue. We have a trapezoid. Since we have marked off that AC is congruent to BD, we know that this is an isosceles trapezoid, which means that our base angles are congruent. So the top angles are congruent, which means angle B is 126 degrees, and also our bottom angles are congruent. And since the top angle plus the bottom angle has to equal 180 degrees, to get those bottom angles, 180 minus 126, and that gives us 54 degrees. So C and D are both 54 degrees. 15, we do not have that the sides are congruent, so this is a ordinary trapezoid, which means that angle A and angle C would have to be supplementary. So to get angle C, do 180 minus 112, and we get 68. And then on the same side, our consecutive angles also have to be supplementary. So if we need to for angle B, we have to again do 180 minus 61. And we get 119 degrees. 16, we have another isosceles trapezoid. We know that AD, this diagonal, equals 3x plus 6. And we know BC is 7x minus 10. Well, in the isosceles trapezoid, we know our diagonals are congruent. So we set our two diagonals equal to each other. And then we solve. We get that x is 4, and then we need to find AD, so I just plug in 4 for my expression for AD. So the AD is 18, and since our diagonals are congruent, BC is also 18. Now everyone's favorites, your coordinate planes. This one's actually numbers, so we're okay. To get to point D, we know we had to go over 4 and then up 4. So we know all of our points are going to deal with 4s, just different positives and negatives depending on our quadrants. So since E is in quadrant 1, positive 4, negative 4. A is in quadrant 4, positive 4, negative 4. And N is in quadrant 3, so we're all negatives, so that's negative 4 and negative 4. Next question, we have, now we're with letters. Yay. So if we look at GR, we have a horizontal line, which means our Y never changes. Since it's a parallelogram, we know AM would also have to be horizontal. So that means our Y value is never going to change. So our point M has a Y coordinate of negative B. Then we need to look at the X's to figure out our length, because we know our opposite sides are going to be congruent. Well, we know we need to do x2 minus x1 to figure out our length. Label our points. So we had the length of GR was C minus negative A, which means that this is C plus A. Keeping it the same pet track, MA, label it. X1 is our M, X2 is our A point. We know it has to be congruent, so it also has to equal C plus A. So we have A minus X equals C plus A. Subtract the A's from both sides. We get negative X equals C. Divide by negative 1. You get that M is the point negative C, negative B. All right, so then we get to number 19. Okay. So we know that ABCD is a rhombus, which means we know all of our sides are congruent. And since AB is horizontal, I can easily find my distance. I just subtract my x's. So I get that the length is 17. So they all need to have a length of 17. Since AB is horizontal, our y value is never going to change, which leaves point B as the point 17, 0. When we find the y value for point D, C is going to have the same y value. To find the x value, though, for point C, well, we know we're starting from 8, and we need to have a length of 17. So let's add 8 plus 17 to get our x value of 25. To find the y value, from point D, drop down your perpendicular. You know that this bottom length here is an 8. This side is 17, and we have our right angle. So to find the height of that, we can use Pythagorean Theorem. 8 squared plus b squared equals 17 squared. 64 plus b squared equals 289. B squared is 225, which means that this is 15. So that means that we went up 15 to get to point D, which means that's our y value. It is also our y value for point C. Yay. 20. How can we use slope to figure out the shape? Well, slope tells us, do we have parallel or perpendicular lines? So we know if we have two pairs of parallel lines, two pairs of opposite sides having the same slope, then we have the parallelogram. If we have one pair of opposite sides having the same slope, we have a trapezoid. If we have two pairs of opposite sides with the same slope and our consecutive sides are perpendicular, or opposite reciprocals, we have a rectangle or a square. Because then that would mean our consecutive sides are perpendicular. And then if our diagonals have the same slopes, we have a rhombus. Or diagonals have opposite reciprocal slopes. We have a rhombus. Rhombus or a square. All right, so our distances. How can we use distance? Well, once we found all four slopes, this is what we're going to do first. We're going to find our slopes first. That'll tell us how many pairs of parallel lines we have. And then distances, if we have all of our sides are congruent, we have a rhombus or a square. If we have our diagonals congruent, we have a rectangle or a square. If we have two pairs of opposite sides congruent, we have our parallelogram, so opposite sides have the same distance. We have parallelogram. And if we have one pair of opposite sides congruent and the other pair is parallel, then we have our isosceles trapezoid. Then the only time we're going to use midpoint is if our diagonals have the same midpoint. All right, I apologize for the delay. My board froze. The diagonals have the same midpoint. They bisect each other, which makes them a parallelogram. All right, so number 21, or finishing 20, if we look at our slopes are 2/7 and -7/2. And then all of our sides have a length. The slopes are this. So we have 90-degree angles. Our lengths of all the sides are the square root of 53, or 7.280. So we have a square. Number 21, we first want to figure out all of our slopes. The slope of the top is 0. The slope of the bottom is also 0. So we know we have at least one pair of parallel lines. Since we want this to be an isosceles trapezoid, we check the slope of the left and right to make sure those ones are not parallel. Well, the left side, we have the slope of the red line is up 6/3. So we have a slope of +2. The length of the right side, which is here in blue, is down 6/3. So we have a slope of -2, which means those two sides are not parallel. So then we have one pair of opposite sides parallel. So we know we at least have our trapezoid. So now, since we want an isosceles, we have to check the length of the left and the length of the right. So the length of the left side, we went up 6/3, so that's 6² plus 3², and we get the square root of 45, or 6.708. The length of the right, we went down 6/3, so that's -6² plus 3², which is still 36 plus 9. So we get the square root of 45 again. So we do know that those legs are congruent. So the non-parallel sides are congruent. So our trapezoid is isosceles. All right, 22, I'm first checking my slopes, making sure I'm remembering that my teacher told me that I had to move that 1 point over because we made a mistake. All right, so we find all of our slopes. The slope of the top line is, again, since it's a horizontal line, it's 0. The length of the bottom line, or slope of the bottom line, is also horizontal, so it's also 0. The slope of the left side is up 4/3, so it's 4/3. And then the slope of the right side It's also up 4 over 3. So we do have that our opposite sides are parallel. So then since we want it to be a rhombus, we need to check the lengths of all 4 sides. So the length of the top is just a horizontal line, so we can just count it. It has a length of 5. The bottom one is also horizontal, so again we can just count, and it also has a length of 5. The length of the left side is going to be 4 squared plus 3 squared, using our up and over method. So that's 16 plus 9, which is 25. And hey, look at that. Our length of our left side is 5. So we 3 down, 1 more to go. Check the right side. Again, we have 4 squared plus 3 squared, which ends up being the square root of 25. So we have all sides congruent. So we have a rhombus. All right, so we keep working through, and we're done with the coordinate plane for now. We're back to our rhombus. We know that angle 1, since that's where our diagonals intersect each other, angle 1 is 90 degrees. Since AC has a slope of 4/5, and that is one of our diagonals, since BD is perpendicular to that, its slope must be negative 5 over 4, the opposite reciprocal. Well, we also know that the diagonal bisects opposite angles, which means that 3 and 4 must be congruent. So we set them equal to each other and solve. So we get that x is 16. Then we are going to use that to find angle 3. So plug 16 into the angle 3 measure. And we get 84. Since they were congruent, you don't need to plug it back in. You know angle 4 has to be 84. Well, your diagonal bisects the opposite angles, which means that since angle 2 is part of the opposite angle from 3 and 4, angle 2 is also 84 degrees. So then we look right here to figure out angle 5. We have a right angle. We know angle 4 was 84 degrees. So the 90-degree angle plus angle 4 plus that half of angle 5 has to equal 180. So we add that up, subtract it from 180. This half must be 6, which means the other half must be 6, which makes angle 5 have to equal 12 degrees. And then since angle 6 is opposite angle 5, angle 6 is also 12 degrees. We move on to the next page. All right, number 24 was the next one where we had to make a correction. Remember, you will end up on your y-axis. Well, we know parallelograms have to have the same slope. So figure out, how did we get from point to point? Well, we went up 3 and over 3. Since we need to end up in quadrant 4, we're going to need to do the opposite of that. Down 3 over 3. So there's our point. Do the same thing for 25. To get from one point to the other, we had to go up 4 and over 2. So start from our bottommost point, up 4, over 2. And there's our point. 26, we have to solve for x. Well, we know BE has to be congruent to DE because our diagonals bisect each other, which means this is 24. And we know that AB has to be congruent to AD because it's a rhombus, so that's 25. We know, we look at the triangle right here, we know this angle here is 90 degrees because our diagonals are perpendicular. So we're going to use some trig to figure out angle x. 24 is our adjacent side, 25 is our hypotenuse. So we are using cosine of x equals 24 over 25. And since we're looking for an angle, we need to use the inverse. So we get that x is 16.260 degrees. For 27, I'm going to use Pythagorean Theorem because I know that all of my halves of my diagonals are congruent, which makes that 9. And I know that my diagonals are perpendicular, so here I have a right triangle. So 9 squared plus 9 squared equals x squared. 81 plus 81 equals x squared. So 162 equals x squared. Square root it, I get x equals square root of 162. Or 12.727 degree, or 12.727. I also could have used my special rights, my 45, 45, 90, so my proportion would end up looking like 1 over 9 equals root 2 over x. So x would be 9 root 2. All of those answers are the same. You do not need to do it in multiple different ways. 28, we have a rhombus and it walks us through each step. We know that BD is 16, which means that BE has to be half of that. So BE is 8. AED, the angle outlined in blue, since it's where our diagonals intersect each other, we know this is 90 degrees. The other information we knew is we knew that AE was 6, and we know that angle ABD, this one outlined here in purple, is 67 degrees. So if we're looking for, if we are looking at figuring out angle BCE, this one here in green, well, I know that EBC would have to be 67 because it's the other half of our angle, and I know this is 90 degrees. So 90 plus 67 equals 157. Subtract that from 180 degrees, and I get 23 degrees. DC, to figure out DC, I have here in red, I'm going to use this right triangle right here. I know that ED is, so I know that ED is 8, I know that EC is 6, so I can use Pythagorean Theorem to find DC. 6 squared plus 8 squared equals C squared. 36 plus 64 equals C squared, so 100 equals C squared, and I take the square root of that. I get C is 10. Since this is a rhombus, all of my sides are going to be 10, which makes my perimeter 40. Next page. We're getting there. We have another rhombus. I know that DM is 5x minus 1, and I know MF is 2x plus 5. I know both of those are congruent because it's our two halves of our diagonal. So to find x, so that 5x minus 1 equal to 2x plus 5. Figure that x is 2. To figure out FM, I can plug it in. I know what MF is. So I plug 2 in for x, and I get that FM is 9. And then I have to figure out the angle of EMF. Well, that's where our diagonals intersected each other, so I know that that's a 90-degree angle. MGF is this angle outlined in purple. Well, it's going to be congruent to angle FEM because they're both halves of our opposite angles. So I know that MF is 9, and I know that, actually, oh yeah. Okay, we have a purple angle here. We know that this is a 90-degree angle. We know FM is 9. Since GE is 24, half of that is 12. And I'm looking for this angle right here. I'm going to use trig. The 9 is my opposite side. The 12 is my adjacent. That's the angle y. So tangent of y equals 9 over 12, which means that y has to equal tangent inverse of 9 over 12, which is 36.869 degrees. Then I need to figure out the length of DG, but I still know that GM is 12, DM is 9. Pythagorean Theorem will give us DG. 9 squared plus 12 squared equals C squared. 81 plus 144 equals C squared. C squared is 225. So DG is 15, and since we are a rhombus, multiply 15 by 4, and we get that our perimeter is 60. Number 30. I'm going to need to use some right angles here, right triangles. I need to figure out angle x, but I don't have any other, I only have side lengths. So I'm going to use this right triangle here to figure out angle BDC, because that'll help me to figure out angle x. So if I use trig, the 4 is my adjacent side, the 12 is my opposite. So I have the tangent of y equals 12 over 4. So y has to equal the tangent inverse of 12 over 4, which is 71.565 degrees. Then I'm going to look at the triangle that uses angle x, which is this triangle I've outlined in purple. Well, I know that this angle is 71.565. I know that DE is congruent to CE because it's a rectangle and our diagonals are congruent, which means I know that those two angles, our base angles, are congruent. So to figure out angle x, I do 180 minus 2 times 71.565. I get 36. No, I don't. I get, yes, 36.869 degrees. So there's angle x. I do the same thing in number 31. Here's my right triangle this time. So I'm going to look at angle DB or BDA. I'm going to label this as angle y. 3 is my opposite side. 11 is my adjacent side. So the tangent of y equals 3 over 11. Makes y equal to the tangent inverse of 3 over 11. So y equals 15.255 degrees. And then I look at my triangle that involves angle x. Again, I have that AE is equal to DE because it's a rectangle and our diagonals bisect each other and they're congruent, which means that angle y was congruent to this angle also. I find x again, I do. 180 minus 2 times 15.255. And I get, 1 second, so x equals 149.49 degrees. Number 32 is given ABCD is a rhombus with BD being 12. That means this whole thing is 12. Well, I know, if I look at this triangle that involves my 40, I know that this is a 90-degree angle. Since my right triangle uses half of BD, I know that this is 6, and I need to figure out AD. So once again, I'm using trig. Here's my angle. X is my hypotenuse. 6 is my adjacent. I'm going to be using cosine of 40 equals 6 over x. Set it up as my proportion. x equals the cosine of, or x times the cosine of 40 equals 6. Divide by cosine 40 to get my x by itself. So I get that x equals 7.832. All right, so number 32. I'm looking for BD. I'm looking for this length right here. So I'm going to use, not even that triangle, hold on. I know my diagonals in my rectangle are congruent. So I'm going to use AC to figure out the length of BD because I know information about this right triangle. I know this is a right angle. This is 30 degrees. I'm looking for my hypotenuse. So from my 30, 5 is my opposite side. X is my hypotenuse, so I'm using sine of 30 degrees equals 5 over x. Set up my proportion and solve. I get that x equals 10. All right, so now for one of the more confusing questions in the packet. It's only confusing if you don't read the directions. So make sure you read those carefully. He's using the quadrilaterals graphed on the coordinate plane below, and only the given information in each problem provide the most precise name. And the information does not build on each other, and we'll see what that means. So for A, we know that the length of KH is the square root of r squared plus s squared, and we know that JG is also that same length. So in A, what we have is our diagonals are congruent. So this quadrilateral is a rectangle because that is the most precise name when all we know is our diagonals are congruent. So then we look at part B. I'm erasing my information for part A because I no longer know that information. Here, all I know is that KJ has a length of R, GH has a length of R, and GK and HJ both have a length of S. All I know is my opposite sides are congruent, so this is simply a parallelogram. Again, now I'm erasing this information. I look at part C. We know that KH and JG both have the same midpoint. This point right here is R divided by 2, S divided by 2. Since our diagonals have the same midpoint, that means our diagonals bisect each other, which makes our quadrilateral a parallelogram again. That's all we know. Next problem. In part D, we know the slope of AC, this right here, is negative r over r. To make it a little simpler, negative r over r is just negative 1. And we also know that the slope of dB is r over r, which is 1. Well, that means, because negative 1 and 1 are opposite reciprocals of each other, so our diagonals are perpendicular, which makes this shape a rhombus. Well, if we look at the information we have in the next problem, we again know that AC has a slope of negative 1 and DB has a slope of positive 1. We know that all of our sides have a length of r, so they're all congruent. That still tells us it's a rhombus. And then when we look at the rest of the information, we know that AD has an undefined slope and DC has a slope of 0. Those are considered our opposite reciprocals. So we have a horizontal and a vertical line, which means we have 4 90-degree angles, which makes this a square. And then we are finally on the last problem. So, looking at the information, we know that DB, or AB, is parallel to DC, BC is parallel to AD, and AC is perpendicular to DB. Because we know this, we know our diagonals are perpendicular, we know we have a rhombus. So we're going to look at these properties with the thought in mind that we have a rhombus. So let's look. We have CBE. Is CBE, is CBE guaranteed to be congruent to BCE in a rhombus? We don't know our diagonals are congruent, so we do not know that we have an isosceles triangle. So no, we are not guaranteed to have that information. Doesn't have to be true. So we look at the next one. ABD is this angle right here, and CBD is this one right here. So what that's saying is that that angle was bisected by our diagonal, which is a property of rhombi. Next one, we have EB. I'm going to keep using my different colors. We have EB squared plus EC squared equals BC squared. We know all these are right angles, so that's Pythagorean theorem. So we're good. Next property. We have BC squared plus EB squared. Well, that's a hypotenuse plus a leg, so that's no. The last property says that all of our sides are congruent. Since we have a rhombus, this is true. And we get to the very end of our review. Hopefully this has helped, and good luck studying.